All right, so now we're recording 7 o'clock. We're doing Calc 2. All right, so you guys have a homework due tomorrow, and from the schedule, it looks like we're going over chapter 5, right? That's all from Calc 1, the end of Calc 1. And then in chapter 6, we've got 6.1, which we're going to start with. We're going to be doing integration by parts. So here I got on the iPad 2 practice problems. So go ahead and get a piece of paper out and start doing these problems. I'll give you guys about 5 minutes, and then we're going to go over them. If you guys need any hints or anything like that, let me know. All right, so we got about 5 minutes. And then I'm going to go over the first one. You guys can see the screen, right? Just making sure. All right, so far we've got 7 people. It also might help you guys to have the book beside you, because some of the time I'll be pulling from some examples and going through those, and then some other times I'll be picking examples from outside of the book. But having the book near you will probably help. Especially later on when you guys have some questions, I can quickly look up the problem that you guys have a question about. If you guys are finishing up the questions, go ahead and see if you can type in the answer into the chat message. I want to kind of see what you guys are getting. You can send them just to me if you would like. All right, so we got our first answer from Liz. Oh, look at that plus C. Good old plus C. Okay, nice. So we're going to go ahead and put these on the back burner for a second. What we're going to do is, let me see if I can go ahead and do this. We can go to a new page. Okay, so screen is blank, but don't worry. We can always go back. So we're going to talk about integration by parts, just as a basic concept first, right? So where does it come from? And of course, if you guys have your book open and you're reading it, or you went to a lecture online, you know that it's from the chain rule, right? So I'm going to go ahead and start setting this up. So if we're going to be taking a derivative of a combination of functions like this, right? And you guys remember from Calc 1 that we've got f of x g prime plus our g of x f prime, right? So now, here's a handy little trick. We're going to go to the next line here, and because these things are equal, we're going to integrate both sides, right? So now what happens on the left-hand side is that we simply just cancel out that derivative, right? So we're going to have f of x, g of x, right? But now, because we took this integral, we're going to still have this integral here, and we're going to take it up the quantity, f of x. I'm not going to write the x part, just like this, okay? And then g f prime dx, right? So this becomes a little handy because if we have something, we have one of these terms, let's see if I can go ahead and highlight this right here. If let's say we had one of these terms in an integral that we didn't know how to do like a u substitution for. All right, so someone said you're not getting anything. Your screen isn't showing anything new. Okay, hang on. That's not good. It's showing up for me. Did anyone else see something different while I was writing? Mine isn't either. It's showing up for me. That's weird. Okay. Not seeing. All right. So anyone? So yeah, everyone can't see anything past the practice problems. Okay. So let me go back to the first page. Do you guys see this new line? No, they don't see the new line. Okay, that's weird. All right. All right. Let's see. It's weird that the practice problems would show up and not the new stuff. All right, so I'm going to go ahead and pause the share, resume the share. Okay. Does anyone see that? Probably not. All right, I'm going to stop the share and then come back to it. Okay. Stop share. And now we're going to come back to the share. Share screen. Okay, we're back here. Does anyone see anything else about the practice problems now? Like this new line that I might have drawn, and I'm going to highlight it. You guys see that? Okay, cool. All right, so I'm going to switch pages. You guys see this now? Okay, awesome. Yeah, all right, so this is what I was talking about. I'll kind of go back over it. So what we had was this guy here. Let's go ahead and just highlight it for you guys. This part, right? We're just taking a derivative. And of course, we're going to do chain rule, right? All of this guy. Now, that's just from Calc 1, right? So now if we take an integral of this first expression, we're going to cancel out that derivative onto the second line, right? So now we just have f times g. But now we've got this integral of fg prime plus gf prime dx, right? So why this is helpful is if we've got this guy right here, this first one that I was talking about before we highlighted it. If we've got a standalone integral that's a little bit too complicated for u substitution, like you guys learned in Calc 1, then we can do something called integration by parts. So how do we manipulate this first or the second line here is we can go ahead and split up this integral and move it over, right? So we can rewrite this guy as saying that we've got an integral with f g prime dx is going to be equal to our f times g. Then we're going to subtract the integral gf prime dx, right? So this is a helpful tool to go ahead and integrate this first guy, right? All we have to do is recognize a g prime and then go ahead and almost kind of like a plug and chug, right? But as long as we understand where it's coming from, we can go ahead and solve some problems. So just like we had on the first page. So what I'm going to do is go back over here, and I'm going to get rid of this squiggle. Okay. So let's take a look at problem 1. Let me do small font. Okay. So we've got problem 1. So we've got this integral. Now, on page 318, we've on this like side note here, it kind of writes out how to keep track of these things, right? So let's go ahead and pick a u and a dv, right? Now, what are these u's and dv's? Well, if we go back here to the other page, we're going to say that this f and g prime are related to our u's and dv's. You'll kind of see that in a second. So what do you guys think we should pick for a u or a dv? So a good example is kind of, or like a good pick, is if you have a polynomial, those go down in power when you're taking derivatives, right? Which is helpful for later on for taking, when you want to take an integral. So you might want to pick the thing that's going to go down in powers as your u, right? Because you're going to be finding a du. Whereas a dv is going to be integrated, right, to find a v. So we want something that's not going to get increasingly difficult, but probably is just okay, right? So when we're looking at number 1, we've got this x as a polynomial, which is going to go down in powers. So we're probably going to pick that as our u. We're going to write ahead and write u as x, and then we're going to see what we have left over is e to the 3x, right? Okay. So we have du is equal to 1 dx, right? or just dx. Let's go ahead and get rid of that one. Now our v, we have to remember, so we're integrating this first guy here. Right? So classic and exponential. If you guys can go ahead and type what you think the integral of this guy is, what v is equal to in the chat. All right, so I'm getting some answers. Cool. All right, so, right, if we have an exponential, if we think about what the thing that you need to take a derivative of would give you this, right? If you had taken a derivative, it would have been just e to the 3x, and then we would have this 3 outside, right? So if we had a 1/3 out instead, we would have been canceling, right? So let's go ahead and e to the 3x, right? And if you take a derivative of this, you can see that we're going to get the dv. Okay. So now in this next line, let's write out, we've got u dv equals uv integral v du. Right? So what does this mean in terms of our problem? So let's go ahead and sub them in. Right? So we've got this integral x e to the 3x. Ooh, don't forget that I should have a dx here. All right, so go back and we have a dx here. Now, this is going to be equal to our uv, so our x times our v, which is 1/3 e to the 3x, minus this integral v du. So we have our 1/3 e to the 3x. And then our du is simply just dx, right? So if we can solve this right-hand side, we've solved the integral that we were asked to find. So we can go ahead, keep this guy. Let's simplify it just a little bit. So we've got x over 3 e to the 3x. And now we're subtracting this integral, right? So we've got our minus. Now, we kind of did one just like that back with our dv and v. Right? So this is going to be a 1/9 e to the 3x plus c. Right? So why the c isn't a negative, it's arbitrary, it's just a constant. So c itself could be negative. So it doesn't really matter if you've got a plus or minus. It's just kind of a notation thing that we typically always just write plus c. Right? And now if we go back up and check some of you guys' answers, let's go, let's see. Okay. Yeah, so a lot of you guys got the right answer. Awesome. All right, so now let's go ahead and look at number 2. So if you guys haven't, go ahead and start number 2. We'll give you guys a few minutes. When you're done, you can type out your message or your answer into the chat, and then we'll go over it. All right, cool. So I'm starting to get some answers. All right, awesome. All right, so I guess we can go ahead and start. If you haven't finished yet, don't worry about that. You can keep working and check your answers as I go. All right, so again, when we're looking at this one, we've got this x term here, right? And that's a polynomial. And of course, those powers are going to go down. So kind of like number one, we're going to do the same thing. We're going to pick u as our x and our dv as this other term. Right? And what this means is we find our du, which is just dx again. And now we've got this v term. So we're integrating sine of 5x, right? Now what trig function gives us sine? So if we're taking a derivative, we get cosine. But if we're taking an integral, we're going to get this negative cosine, right? And this 5 doesn't become 5 outside, it becomes a 1/5 because we're taking an integral, right? So we want these to cancel, so I should put negative 1, and then cosine 5x. Right? So now we have our u's, v's, and our du's and our dv's. So we can go ahead and start finding what our integral is. So we can go ahead and write this integral. And of course, this is going to be equal to, now we've got our uv term, which is x times this negative 1/5 cosine 5x. Right? And now we're going to be subtracting the integral v du. So I'm going to just go ahead and take out that negative now, make that a plus. Right? Cosine 5x. And our du is just dx again. Right? So now this guy is equal to, we're going to tidy this up a little bit. Right, we got that first term. Now, again, we've got this positive trig function. We've got cosine, and we're going to get a sine out of that, right? And that 5 is going to become that 1/5 out again. So we're going to have 1/25 this time, right? And then just sine of 5x plus c. Right, so our first term here is negative, and our second term here is positive, and our plus c is arbitrary, right? Okay, awesome. You guys have any questions? And those are pretty easy questions to start off with. Does that look better? That's a little fatter, but okay. So why don't we go ahead and see if we can grab a harder problem. So there are some problems where you'll have to use combinations of integration by parts and u substitution. Possibly you get to a problem where the first thing you're going to be doing is integration by parts, and then the integral that you're left over with that you're subtracting might be something that you can solve with a u substitution. Or perhaps you might even have to do integration by parts again on that integral. So let's say if we had made either one of these problems, instead of just an x, we had an x squared. we would have had an x in the second integral. So let me write that out. So if this was an x squared, let's look at number 1. If this guy was an x squared instead, right, we wouldn't have simply just had this dx term here, right? The x would have showed up in this guy, right? And then we would have had the original integral with a constant, or like a multiplicative constant, but we would still have something like that. Then we would have to do integration by parts again. So there's actually certain types of integrals are actually solved by doing integration by parts a certain number of times, but you never actually get rid of the integral. You'll just get to the same integral again, and you could move everything over and solve it for it algebraically. Most of the time that happens with trig functions. Maybe you guys will see one of your homeworks, or maybe we can see if we can pick one out. So let's see, let me pick another problem here. Ooh, this is probably one that, okay. So I'm gonna go ahead and go to the third page here. We're gonna start. So let's do number 3, and it is the integral e 9x times cosine 2x dx. Now notice that both of these terms, when you take integrals or derivatives, that you're going to be getting exponentials and trig functions back. So it doesn't look like you're decreasing the power of anything, which might seem a little weird because the last time we had a polynomial to work with, and those were going down in power. So eventually we could find the integral using just knowing what the integral was, or u substitution or something like that. But now we've got these terms that are cyclic almost. So go ahead and try out the problem. We'll give you guys a few minutes, and if you guys got the answers, go ahead and send me a message. All right. I'm going to see, I'm going to go step by step here. Okay. So let's go ahead and we're going to set our U and our V's or DV's here. Right? So I'm going to pick U to be the sine, or I'm sorry, we're going to pick this cosine. Cosine to x, and my dv being e to the 9x. Right? Let me see if I can, okay. So you guys, can you still see where I'm writing? Okay. So let's go ahead and find our du and our v. Right? So now we've got this cosine term, and we're now taking this derivative. So we're going to get this negative sign, right? We're going to get negative sine 2x, and let's not forget our multiplied by 2, right? And then we're going to have a dx term here. Okay. Now for this v, we're integrating our e to the 9x. So we're going to get this 1/9 e to the 9x term. Okay. So now let's go ahead and plug this guy in. So we are looking for our uv minus our v du, right? So our uv is this 1/9 e to the 9x cosine of 2x. Then we're going to be subtracting our integral here, our v du integral. So we have our 1/9 e to the 9x, and now we're multiplying it by this negative sine 2x to dx. All right, so that doesn't look like it helped us all too much, but you'll kind of see what I'm getting at here, is now we've got this other integral here that we're going to be wanting to do another integration by parts on, right? And you might see what happens if we do another round of that. That sine will turn into a cosine. So let's go ahead and we're going to do another u dv combination here. So we've got u and dv again. So this time I'm going to pick kind of the same thing. I'm going to pick sine here of 2x. It's my u, and my dv, I'm going to keep it this. We could have combined the constants. Doesn't really matter. We just have to keep track of it. Okay. You guys can't see my work. Oh, shoot. Okay. You guys can't see anything. Okay. Well, let me stop the share and let's do it again. It's kind of weird that it's going back and forth and not working. So doing this. Share screen. Okay. Can you guys see what I've got going on now? Okay, awesome. Sorry that that keeps happening. I'll try to look into it. I don't know why it randomly just kind of stops sharing the screen. What I was talking about before is we had this, on this, the first step are U and DVs, and we are finding what our U and DVs are, right? Our DUs and Vs, and kind of look at my work there. It's not too much of a jump on that first line here, right? And then our integral is this UV minus this VDU, right? And that's back from over here in this page, right? We have our, let me do a different color. We've got this guy here, right? This is what we're using. And that's just me writing it out. So we're finding this integral, those things are equal. So all I'm doing is just plugging in what our U's and DV's are, and this this yellow highlighter, this guy right there, is what I was talking about, is that it doesn't look any better, right? Because it has this sine term and it's got this exponential term, and it's not quite clear why this is a step forward rather than a step back. But if we look a little bit closer, we'll see that if we do the same kind of performing operator again, right? Whatever we're doing, we're going to get this sine into another cosine, and this exponential is going to stay the same, right? So we're going to get something that looks almost like the first integral, and you can kind of see what's going to happen. But we're going to move forward and show you guys what's about to happen. So we have our U sine x, or sine of 2x here. So this is going to mean that we've got this 2 out here. Now we're going to have a cosine 2x dx. And now we've got this v term, and we're going to have 1 over 81 e to the 9x. Okay. So again, I'm going to write out what we've got. We've got this 1/9 e to the 9x cosine. This is from that first relationship, right? Because all we did was solve for this integral. So I'm going to put brackets here. Now this is the new stuff. Okay. So we've got our new u and v, so 1 over 81 e to the 9x sine 2x, right? And now let me back up for a second, and that minus sign is actually a plus, because if we look back at that line, we have a minus sign. We have a minus sign, right? So we're going to have a positive. It's a little bit hard for me to point when working on this thing, but we've got this minus here and that minus there. So I'm going to make that guy plus. Okay. So now we've got this integral here, which is now our v du. So we have 181, and then we've got this 9x, and our du here, I lost track of myself. Okay, we got 2 cosine 2x dx. So now let's not forget that inside that original integral we had a 2, right? And we didn't include that in any of our u's and our v's, so we can't forget that, right? So now, here we go. We're going to try to simplify this a little bit. But before we go ahead and do that, I want to kind of point out, we've got this exponential here and this cosine here, that if we look back at the original problem, and the others are just constants, we basically have the same integral. So what we're going to do is we're going to solve for this integral in terms of itself and move it over algebraically. Which I always think is a cool implication of integration by parts. So this is going to get a little messy here, but we got e to the 9x cosine 2x. Also, we shouldn't really forget our plus c here, huh? Okay, so now we've got this plus here, and we've got 2 times 81 e to the 9x sine 2x, right? And now we've got this minus, and hang on, I'm going to actually write all the constants out in front. We've got 2 over 81, actually 4, right? Got 4 here. 4. The integral of e to the 9x cosine of 2x dx plus c. Okay. So now we've got this original integral right in here. And we can solve for that because it's on the left-hand side from the very beginning, right? So what I'm going to do is write out the whole relationship that we've got now with moving the integral over, right? Because we had one of those integrals, we're going to start with that 1 there, and then we're going to add this 4 over 81 of the integral, right? Right? Because we started off with this original integral and we got it back, but with a constant out in front. So we're going to add that over, cancel it on both sides. Right? Now we've got what's left over. This is a little bit messy. It's e to the 9x sine 2x plus c. Right? So now all we need to do with this next line is divide over the constant in front of the integral. Right? And this guy right here, so that's 81 over 81 plus 4 over 81, right? So now what we've got there is 85 over 81. And all we do is multiply the other side by the reciprocal of this, right? So our final answer, this integral, the original integral, is just going to be this 81 over 85 of what we had on the right-hand side, 9x cosine 2x plus 2 over 81 e to the 9x sine 2x. And I'm going to write the plus c out here like this because a multiple of c is still going to be c, right? Still a constant. Some things will cancel there, like the 81s and one of the 9s there. It doesn't matter too much. We can do some kind of simplification on this next line. Right? So one of the 9s is going to cancel, and we're going to have 9 over 5e to the 9x cosine 2x plus 2 over 85 e to the 9x sine of 2x. Right? And then plus c. And that's our final answer. So the whole thing that I was talking about is we had an integral, and we did integration by parts on it a certain number of times. In this case, we did it twice to get the original integral back, but with some extra terms. And then we solve it algebraically to find the right answer. I think it's kind of a neat way to do integration by parts. Okay. So we've got about 13 minutes left. So if you guys have any questions, let me know. I can't directly write out the answers for some of the homework problems, but you can ask me if you're having trouble with the homework problem, and I can give you hints and lead you to the right way, or even do another problem in that problem grouping. I know some of you have already started trying to submit your homeworks. Make sure that they follow the guidelines. I think it's on the website, the exact format you should be using. There's some apps that you could use, free apps on Android and Apple to scan your homeworks. Okay, so someone's asking if we can do the integral of arctangent 8x. So that's a little bit different. So question is, arctangent 8x dx. I'm not sure if it had bounds or not. I'm guessing it's indefinite. Wait, you guys don't see the new stuff. Shoot. All right. yeah, I'm writing it. All right, let me stop the share and restart it. I think what happens is whenever I start a new page, it stops sharing, which isn't convenient. So I would like to have the sharing, go back to the page that I'm working on. Okay. All right, so here is the question, the integral of arctangent 8x dx. So it might not be completely apparent, but this is actually an integration by parts problem. So it's a little bit tricky. So what we're going to do is actually set u equal to our arctangent of 8x. And then we're going to have our dv here as just dx. This makes our du. So now from Calc 1 in Chapter 5, we know what the derivative of arctangent is. So we're going to have the chain rule here. So we're going to get this 8 out in front, and then we're going to have 1 over 1 plus. Now it's this inner thing squared, so we're going to have a 64x squared here. Okay. Now the v term is just simply going to be x then. Right? So now putting this into what we have our, so we need u times v, so that's our x times arctangent of 8x, right? And then we're going to be subtracting our integral of v du, which is now x times this 8 over 1 plus 64x squared dx. So the second integral now, this guy right here, is we can do just a simple u substitution. So what I'm going to do is make my u here this 64x squared plus 1, just the denominator there. And when I find my du, I'm going to be getting a 128x dx. Okay. So we're going to go ahead and just look at this integral here for a second on this next line here. And so now this integral is, so we have an x and we have this 8. So we're going to have this 8 over 128, and we're going to cancel one of those x's, and then all we have left is 1 over u du. And that guy is equal to our 1 over 16. That's the 8 over 128 is 1 over 16. And then the integral of 1 over u du, which is just natural log. Now I'm going to sub in what we've got for u here. I'm not going to put absolute values because that quantity is always going to be positive. So it doesn't matter too much. Right? And of course, we're going to have a plus c, but we're going to wait until we go back to the whole problem here. So now I've got my final answer here as x times the arctangent of 8x minus 1 over 16 natural log 64x squared plus 1 plus c. All right, and that is our final answer. I'll just go ahead and highlight that. And then, of course, that was the answer for this guy. All right, I hope that helps. Just remember to turn in your homework on Thursday, and I will see you guys on Monday. All right, take care.